So our topic at hand today is EVAP systems. We are returning to EVAP systems at long last. We've talked about them a couple times a few years ago, but some things have changed. Some things have been a little different. So we're just going to kind of talk about it and kind of talk state of the art or industry, as it were, right now with our EVAP systems operation and testing. So first off, we got to go through the different components because there are a few different main components that are going to be the same across the board when you're talking about an EVAP system. First off is the purge solenoid. That's going to be up in the front, closer to the engine, usually. And that's going to allow the gases in. Then we have our vent valve. We have our canister. We have our fuel tank pressure sensor. And then we might have some pumps or associated modules depending on the vehicle. So it could be called an NVLD, ESIM, DMTL. Bunch of different manufacturers have a bunch of different acronyms for it. But that is, basically you're going to have a purge valve, vent valve, canister, and a fuel tank pressure sensor. Maybe you might have the extra associated modules along with it, but for a basic system, you don't necessarily need it. So here is a basic system here. We got our fuel tank here. We got our canister there. And the first thing we'll discuss is the purge solenoids. Like I said, it is up closer to the engine usually. That is the entrance to the engine from the canister. So it is usually a pulse width modulated controlled solenoid, so it can open it variable amount or a variable amount of time. It allows the EVAP vapors into the engine, like I said, and it's also used for leak testing. It can close off the system once we've drawn a vacuum into the system. It can close it off. Now, in some vehicles, like I believe it's on a turbo Honda, they may have two purge solenoid valves because we have one pre-turbo and one post-turbo. So it's going to be for boost. So depending on how much boost I have, I may need to make a transition there to vacuum. So we're going to have one here that kind of goes in on the, like right after the boot there. And then we're going to have another one that's kind of like our switching valve there. So it's kind of like a three-way valve that goes in there. So there's two different ways. And we can see here, we're going to have our canister purge valve. It's going to go into a non-return valve B, which is going to be a merge point before the turbocharger, or non-return valve A, which is going to be a merge point after the throttle body. So it just kind of depends on whether we're under boost or not as to which direction it goes. So if it's under boost, it's going to go into the vacuum side of the turbocharger, the inlet side of the turbo. If we're not under boost, it's going to go in after. Then we have the vent solenoid, which is going to be like the back door, the exit, or the entrance, as it were, depending on what mode we're in, for our fresh air. So that is going to be on the back side. Usually it just vents to the atmosphere. It's an electronic solenoid. Usually it's just open or close. It allows the fresh air into the canister when we're in purge. And it's also used for leak testing. It could close off the system. And it also, in modern systems, may be part of the canister. So it could have a vent valve, just kind of part and parcel of the canister. We'll probably see some pictures of that in a little while. And this leads me to an important safety recall that happened a few years ago on Mazda 6. Now, this is not just on Mazda 6 vehicles, on multiple different vehicles. We had the same problem at Subaru. It just didn't get to the point where we had to recall any vehicles on it. But what happens is, on certain Mazda 6 vehicles, a certain type of spider, this little guy right here, may weave a web in an evaporative canister vent line, and this may cause restriction in the line. If this occurs, the fuel tank pressure may become excessively negative when the emission control system works to purge the vapors from the canister. As the canister is purged repeatedly during normal operation, the stress on the fuel tank may eventually result in a crack, potentially leading to fuel leakage and an increased risk of fire. So one of the main symptoms you're probably going to run into first, and like I said, it's on more than just Mazdas. It's very common. When you run into this, the customer's first complaint's probably going to be, hey, I know my tank's like pretty empty, but I can't put any gas in it. That's usually going to be the first complaint. And the reason for it is because they have a web in the vent line. And it is thick enough of a web where it will not allow the fresh air out of the canister in order for the fuel to, it won't push the fuel out of the tank through the canister like it's supposed to. Now, under normal operation, when there is no more air escaping the gas tank, that is how the fuel pump knows that there's no more room for fuel. All my air is expelled. So that means that it is time to shut off, and that's how they automatically shut off. There's no air. The air starts coming backward. So if it sees that there's no air escaping the tank, it just thinks that it's full, so it's just going to shut off. So pump, click, pump, click, and then the customer will say, well, I can't fill my tank. 9 times out of 10 in my experience, this is going to be the problem. And this spider is native to anywhere in North America and also a lot of Europe. So it can happen, in 2 of our major markets at least. So you can see there is the web, and it looks pretty full. It looks like a cotton ball, really. And all you got to do to get rid of it is just squirt a little air in there, and it'll come out and it'll pop out. It kind of looks like that when it's collapsed. You just clean it out real good. Make sure you squirt it away from yourself. You don't need a spider in the eye. But yeah, that will be enough to cause an EVAP problem, a flow problem. You could, nowadays there's flow codes, so you could get a flow code, insufficient flow, when it's on purge. So just be aware that that is a fairly common occurrence, and it's pretty easy to check. Just check the vent line where it comes out and see if it's in there. I guess they must like the smell of vapors or something. But it can cause a problem with air escaping. It can also cause a problem with air coming in when I'm in purge. So when I'm in purge, it'll cause excessive vacuum, and it could cause a fuel tank to collapse in other cases. Now, other times I've seen this too, it's not with a spider. It is on, I know, like a lot of GM trucks, like Tahoes and Silverados and stuff, where the vent valve's kind of in a weird spot in the back. And you can get a lot of road debris up in there, mud and crud and stuff like that, and that can cause it too. So just be aware that that was an issue for a long time, where it would cause the fuel tanks to collapse as well. So if any of that happens, that's an easy thing to check. Visual check, see if it's clogged. If it is, good place to start. All right. Next, we're going to get to the canister. So the canister does what it says on the tin, right? It collects EVAP vapors. So it'll hold it in a canister, contains activated charcoal, and it may contain electrical components as well. So the activated charcoal is what's going to absorb those evaporative vapors and hold them until it's time to purge them. It may contain electrical components, like I said. So in this example, you see we have the vent valve, which is part of the whole canister assembly. So you may, if you need this vent valve, you may have to buy the whole canister, and vice versa. If you need to buy the canister, you may have to buy the vent valve with it. It's kind of how it goes nowadays, I guess. And then we have the fuel tank pressure sensor. That is going to tell the computer what the pressure is or what the vacuum is in the fuel tank, and the computer can react accordingly depending on what it is. So it measures fuel tank pressure. It is a 3-wire sensor. It's going to output a voltage depending on pressure. So it's going to have voltage, signal, and ground. And then it's going to have a variable voltage going back to the computer to tell the computer here's what pressure it is. So in this example, we have on our 2016 Chevy Tahoe fuel tank pressure sensor. Going to have a signal, low reference, and a 5-volt reference. So key on engine off voltage would be about 1.3 to 1.7 volts with no pressure or vacuum. Remove the gas tank to make sure there is no pressure or vacuum. So just kind of pop the cap off. Replace the fuel cap. As vacuum builds in the tank, voltage will increase. With pressure, voltage will decrease. So kind of static at sea level should be 1.3 to 1.7 volts. To do this automatically, however, manufacturers have started putting in leak detection devices. So in this example, we have a pump assembly, leak detection pump assembly. So this is off a Subaru, and it's got all sorts of hoses and bells and whistles and stuff. It's got a little pump there. So the leak detection pump and sensor are used as a pair to not only detect evaporative leaks, but also to detect the size of the leak so it can quantify it. The leak pump will draw vacuum on the evaporative system. Pressure sensor will monitor the system in the tank and look for any leaks. A drop in voltage would indicate a leak in the EVAP system. Leak detection pump is part of the vacuum pump module assembly, combining a vacuum pump with drive motor, canister, vent valve, and pressure sensor. ECM commands the vacuum pump to apply vacuum to the EVAP system during self-test. To test either the canister, vent valve, or pressure sensor, go to EVAP system in the main menu. None of the internal components can be serviced separately. If any fail, the vacuum pump module must be replaced as a unit. So it's an 8-pin thing. Got the vent valve, leak detection pump, pump ground, canister, vent valve, 5-volt reference, and a sensor. So it's got a sensor, it's got the canister, vent control valve, it's got the vent valve, and it's got the leak detection pump all as an assembly. It's located behind the left rear seat under the cargo area and steel guards. Now, don't think the steel guards are going to stop anybody either, because when they first came out with this, had a new model year update class we'd have to go through every year. They said, yeah, watch out for somebody screwing a screw through there to mount their subwoofer, amp, or whatever in the trunk. And then all of a sudden they get an EVAP leak because they put a self-tapper through it and it goes through the thing. Never actually saw it personally, but I could see how it could happen. I also said, due to internal circuitry to leak detection pump, motor resistance cannot be checked. Toyota Avalon, many Toyotas, is going to have the same exact system because Toyota owns part of Subaru, right? So they carried over a lot of that technology. One thing to note with these, though, Toyotas, Subarus, what have you, the monitor checks for EVAP system leaks and canister pump module malfunctions. The monitor starts 5 hours after the engine switch is turned off. So you need to wait for a cold soak on that. At least 5 hours are required for the fuel to cool down and stabilize the pressure, thus making the EVAP system monitor more accurate. Leak detection pump creates negative pressure in the EVAP system. The pressure is measured. Finally, ECM monitors for leaks and malfunctions, both canister pump module and purge valve based on EVAP pressure. And if it's not cool enough, 95 degrees Fahrenheit or less, 5 hours after the engine switch is turned off, it's going to wait two more hours. If it's still not cool enough, 7 hours after the engine switch is turned off, it's going to check 2.5 hours later. If it's still too hot after that, I don't know. Doesn't really say. But that's 9.5 hours letting the car sit. So overnight, theoretically, it should be cool enough. But I suppose if I live in a desert and it's 100 degrees, low temperature, could be a problem. But yeah, that's how it's going to check it. So there are ways on many vehicles that have these systems to force it. So we'll look at one on a Toyota in a little bit. But there is a way to bypass that cold soak on many vehicles. And then it'll just say the monitor will not run unless all these situations have been met. And it'll run it after, like I said, five hours after the fact. Chrysler has eSIM module, so it's a little vacuum operated little thing there. It's called the EVAP System Integrity Module. So it's very similar to NVLD, which would be natural vacuum leak detection, which is the older system, and some manufacturers still use natural vacuum leak detection. The design of the eSIM has been simplified so it does not require a solenoid. eSIM mounts directly on the canister, eliminating need for a mounting bracket. Critical eSIM is mounted vertically, so if it's mounted incorrectly, it won't work. On vehicles where the canister is mounted at an angle, the eSIM requires an adapter to maintain a vertical position. When the eSIM is installed vertically, the electrical connector is in 3 o'clock position. It consists of a housing, a small weight, and a large weight that serve as check valves, the diaphragm, a switch, and a cover. There's one large weight and one small weight to check valve in the eSIM assembly. A seal is attached at the end of each weighted check valve. The large weight check valve seals for pressure. Small weight check valve seals for vacuum. Weighted check valves are contained within the housing itself. So that's how it's going to check. It's a check valve. We have the BMW DMTL, which is their older system. They actually started using natural vacuum leak detection lately. But that stands for Diagnostic Module Tank Leakage. So it's a German acronym. And then there we have here under the engine, going to have a functional test, EVAP tank leakage diagnosis, DMTL. There's a little theory and operation, tank leak test, system actuators, diagnosis and symptom tips. So theory and operation is going to tell you how it works. I'm not going to read through this whole thing, but it'll tell you whether or not it has a large, small leak or no leak. And it has a leak detection pump as well. Diagnosis and tips. Once again, not going to read through all that, but it's going to tell you how it would work and what the process for that is. So now that we kind of have a grasp of the different components of the system, let's talk real quick about how it actually works. How does this system work? So this is the system here. So our purge valve is our front door, our vent valve is our back door, and then we have our fuel tank pressure sensor here. We have our canister here, and we have our fuel tank here. So under normal operation, the front door is going to be closed, so the purge is closed and the vent is open. That allows fresh air to evacuate from the system. So I'm going to fill it up with fuel. It's going to displace the fresh air that's in here. It's going to go out. It's going to start making vapors as it does so. And it's going to push that fresh air out into the canister. It's going to collect the vapors. All the fresh air is going to go out the back end, out the vent. Then when it's time to purge, engine's going to warm up. When it gets to a certain point, the ECM is going to open up the purge, and allows the fresh air back in through the vent. It's going to displace the vapors. And it's going to go back into the engine under a vacuum. Once that's done, we're going to continue drawing a vacuum on the system, and then we're going to close the vent, which is going to allow us to draw down a vacuum on the system, and then fuel tank pressure will go negative. Once we're in a vacuum state, it's going to close the purge valve, and then it's going to maintain that vacuum. And it's going to see how long it maintains that vacuum. It's going to start a timer. In this case, it's going to be 20 seconds on this animation, but it's going to measure the amount of decay of that vacuum. If the vacuum does not decay, like it's in this case, that means no leak. It can hold a vacuum. It's just like checking an AC system for a leak. Same principle. However, if it does decay, it is going to measure how long it takes to decay, and by that, it can then quantify the size of the leak. So if my vacuum decays quickly, I have a large leak. If it decays very slowly, I have a small leak. Makes sense. Size does matter, especially when it comes to codes. Now, the other thing about codes that you want to think about and take into consideration when you're doing EVAP work is read the definition of the code. Don't just see the word EVAP and assume it's a leak, because we have leak codes 440, 442, 456, 457. We also have electrical codes. So a 443 is a problem with the purge control valve, 446 a vent control valve, and so on and so forth. So always suss out and always check and see, is there an actual leak or is there an actual electrical problem? Because that's going to obviously change the way you're diagnosing the problem. Of course, we know EVAP leaks can be a huge problem, and they are a huge problem. They're one of the top, however many percentage of code. But electrical problems can be problems. I know one that I can recall very vividly, that somebody called me up and said, "Hey, I've replaced a whole bunch of stuff on this thing, and it still has an EVAP code. What can I do?" And then look up the code and actually come to find out it's an electrical problem. It actually ended up being the purge solenoid was bad inside, like a resistance problem with the coil. So it's not always a leak. It can be an electrical problem. But if it is a leak, how do I test it? Well, I need some way to test the leak. Now, in this case, this slide right here, I have the our Smart Smoke EVAP emissions tester, EELD 500. It's a part number. This is still, as far as to my knowledge, the only digital display EVAP tester on the market, so it can actually quantify the size of the leak. Not only will it put smoke into the system and see where it's leaking out, but it can quantify the size of the leak. If it's 40 thousandths or over, that's going to be 1999 and older was the spec for that. 40 thousandths and older it's going to set a code. 2000 and newer, 20 thousandths is going to set a code. And then actually a lot of Chryslers nowadays is 10 thousandths, and there may be vehicles out there with a spec of 0 thousandths. But that's just what we're going to do. In this case, there's a leaking vent valve, so we got to fix that first. We put smoke in and vent valve's leaking. Well, I can't seal the system if the vent valve's leaking. That would probably throw a code nowadays, but on an older car, it probably wouldn't. Here's an example of a cross-threaded sending unit. So they didn't realize they cross-threaded. It was like a technical high school. They replaced the sending unit, didn't realize it was cross-threaded. Smoke coming out there. Here we got a cracked hose. That's a lot easier to see, but you can definitely see where it's coming out under pressure. So that's why you need to test it with both smoke and being able to quantify the size of the leak too. So I know, is this going to set a code? It may still leak, and it could be below the threshold for a code too. Could have 8 thousandths of a leak, right? Instead of 10 thousandths. That wouldn't set a code. Wouldn't be enough to worry about to set a code. That's why you want to quantify it too. However, it's an electrical code. I need to test it electrically, right? So here's an example from our guided component tests, where we have an example for a purge solenoid. So if it's a electrical code for a purge solenoid, I might need to test it here. So in this example, normally closed solenoid, use to purge fuel vapors from the EVAP canister. These vapors are purged back in the intake manifold. We talked about that. Let's see. EVAP purge function remains unchanged from previous OEM system, but EVAP VSV now has added function during vacuum pump-based EVAP system test. So this one has the self-test. The vent solenoid valve for EVAP is an electromagnetic solenoid valve that is pulsed on-off when energized by duty cycle command from the ECM, the purge canister, or remain at proper time during key-off EVAP self-test to release vacuum from the system. So that is how it releases vacuum after the pump pulls it down. And then it goes on to tell you a little bit more about it, right? So it's 12 volts in ground. Pretty simple to test. We're actually going to look at that here in a second. But that's what you would want to do. If it's an electrical problem, test it electrically. If it's a leak code, then leak code. So let's look on the tool at a couple cars and see what we can see. First one I want to do is this Camry. So all the EVAP stuff, of course, will be under engine. And it'll be under functional tests. And then we have some under special functions that might be depending on the vehicle. In this case, it's not under a special function. There's nothing under there. But we do have some actuator tests that we can do. So activate the EVAP purge vent solenoid valve, activate the vacuum pump for that as well. Vent valve, fuel vapor containment valve. This actually has a separate valve in there as well to kind of separate the fuel tank from the rest of the system. So that's a fuel vapor containment valve. There's also intake control. So that's actually a different vacuum switching valve. See, they use VSVs a lot. VSV as an acronym a lot in Toyota language. So EVAP purge vacuum switching valve and the vacuum switching valve for the vent valve. So kind of need to know that, the difference in between. I did want to see, actually I should check and see. It's not under here, right? It's not under here in the simulator. I think it's actually under routine test, but it's not going to give me any routine tests in the simulator. So you would see it under special functions or routine tests when you're hooked up to a car. Simulator sometimes doesn't show everything in here. So just so you're aware of that. Your mileage may be different on your own vehicle or the vehicle that you're working on. Now, if we go into repair information, a couple things come up. So this is a 2-year-old car, 3-year-old car now, I guess. 85,000 repairs though. And then let's see. So for example, PO 441 right there, number 4. Incorrect purge flow. Gross leak there. So 2 of the top 10 codes are for an EVAP problem. If I look over here, I don't see anything. Over here, I don't really see anything. But let's pull up that number 1 code. And then we'll just look there. And we can see OEM test procedure for this. So it's just going to walk you through what you would need to do. So it could be an open and short in the circuit. Could be this purge valve itself, canister problem module, purge line, etc. There's a bunch of different possibilities it could do. And it's just going to walk you through how to do it. Gives you a couple of diagrams of how the solenoids work and how the flow should be with that. Whether it's stuck open or stuck closed, what's going to happen. All sorts of good stuff in there. You could even have subcodes in there, like the 441-7F, right? This could give you a different subcode as well. Wiring diagrams. And I can just take a look at the engine performance circuit. It's going to be your canister pump module right there. In that case, there should be some more solenoids in here too. It's on one of the later pages. It's a transmission function. 10 pages long. Love it. Injectors. Purge valve. There we go. Vent valve. So if I were to go in here, we got the vent solenoid. It's going to share power with the purge valve as well. And with the water valve, I guess. So if one of these goes down, it could cause problems. It could cause a problem at that junction right there if I don't get power to one or the other. I mean, a lot of times these are on the vent valve for sure is usually under the car. So could be an issue there. Just a couple things to look at when you're looking at that electrically, right? Let's look at a domestic here. We'll look at Ford Escape. So on the Ford Escape, Under special functions, we're going to have a EVAP system cold soak time bypass. So that's another, this one must have another wait time before it runs the EVAP test. So erase freeze frame data, OBD monitors, and engine transmission codes. So key must be on. I don't know how far this is going to let me go in the system. There we go. And then I'll run the monitor. And then you would drive it to run the monitor. Gross leak test as well, small leak test as well. So a couple different things in there related to EVAP for that. If I were to go to guided component test too, we'll be able to see under EVAP system. Got a vapor blocking valve, so that's what we were talking about before on that Toyota. But this Ford also has one. EVAP vapor blocking valve is normally open valve. PCM closes the blocking valve to isolate the fuel tank from the rest of the EVAP system. EVAP vapor blocking valve will automatically open or relieve excess pressure or vacuum in the fuel tank. And it's just an open and close. So power and ground. Purge solenoid. This one has a location image, which is handy. So it looks like it's up front, up top, kind of near the snorkel there. Left center of engine bay mounted next to the intake air tube, master cylinder brake fluid reservoir. So it's like right in there. There's the master cylinder. It's kind of right next to it. Right there. Helpful information. Then a signature test, you're going to see it's a pulsive modulator, right? So you're going to have a square wave pulsing. So fuse 35 or circuit breaker, canister purge valve control. Resistance, it's going to be 15 to 25 ohms. That's going to depend on how open it is too. Component information just kind of tell you how it is. So it's a duty cycle between 0 and 100%. And then if we were to look in shop key, this is a little older, so it's got 127,000 repairs. So that's an EVAP code number 3, number 5. All right, EVAP system small leak detected. EVAP flow during a non-purge condition. So if we were to pull that up, wiring diagrams there. All right, so there's my vent. There's my purge valve there, so it's going to share some stuff, some power and ground. See that. Testing. It's going to tell you what the parameters are, and then go to pinpoint test, and it's going to walk you through the pinpoint test. It's going to tell you how to test it. It's going to want you to test the canister purge, and so on. But once again, all that information is also within your guided component test. If you have a tool with guided component test, I've got some diagrams. It's going to walk you through the different components of the EVAP system. Remove and replace. It's going to walk you through where that is. And then if I wanted to go through the whole EVAP system, see where each of those things is. There's that emissions blocking valve. All right, so that's between the tank and the canister. It also has a electrical connector. A lot of information in there. Best bet is to check your repair information when in doubt. Wiring diagrams can be a huge help. Lastly, we'll check this BMW. That's going to be, they used to run DMTLs. Now it should be a natural vacuum leak detection. So this is... there it is. Tank ventilation valve, solenoid valve. All right, so you can go in there, turn it on and off. Vent valve. And then in guided component tests, we should have some too. So NVLD unit, like I said, runs natural vacuum leak detection. Unlike the conventional leak detection system, NVLD system operates off a natural vacuum. Natural vacuum occurs in the sealed fuel system after it starts to cool and the pressure drops. After a predetermined amount of time and the temperature is dropped enough, vacuum will build up and close the vacuum switch. Vacuum switch is monitored by the NVLD diagnostic module. If the pressure in the fuel system remains high and the temperature is dropped below a predetermined value, NVLD diagnostic module will report back to the ECM and the leak is present, or the vacuum switch closes and then opens again after a predetermined amount of time. Follow set for leak. So that's how it tells. So you're going to have air in the system, As it cools, of course, that air condenses and it'll cause a vacuum. Once it trips the switch, it knows that it's in a vacuum state, and then it measures for how long it's in that vacuum. Test is long, about 12 hours, and the vehicle must be in a rest state to do it. No short test is possible with this type of system. That sounds like a blast to diagnose. So yeah, good to know. Got to let it sit for about 12 hours to make sure it works. So let the customer know you're going to need it for a while. All right, so that is EVAP. Hopefully you picked up a few more tips and tricks than you had when you got here. Hopefully you learned a little bit more. I think the biggest thing to take away from this is just to always remember, what is the code telling me? Is it telling me it's a leak, or is it telling me that it's an electrical problem? Because obviously diagnosing a leak or an electrical problem is going to be two different things. Unless it's like one of the valves is stuck open, then it could be both. Or it could be a leak and an electrical problem. So just be cognizant of what your code is telling you, and that should help you go a long way. And also make sure you have some sort of leak detection device, a smoke machine of some sort. I know we struggled a lot at the dealership because they wouldn't get us one. And finally, we had one that was just like a bear to diagnose, and we finally had to borrow one from next door, the dealership next door, which is a sister dealership. And lo and behold, we found it pretty quick. So, didn't want to say I told you so, but I told them so. I'm like, I could have found this like a couple weeks ago, and the customer wouldn't have had to come back. But anyways, learn from our mistakes, or at least our headaches that we had, and make sure you have at least some sort of a smoke machine to test those. All right. Let's talk about next week. Next week is going to be our last brand new class for the year. And we are finishing out our OEM-specific training classes. And the last one to go is going to be Subaru. I don't want to say I saved the best for last, but this is the one I have the most experience with. So this is going to be the easiest one to write. So it was OEM-specific training on Subaru. See what makes them unique. See the weird tips and tricks and fixes that we have in there. And there's some weird stuff that these things do that I haven't seen any other manufacturer do ever. So Subaru just kind of marches to the beat of their own drum. So hopefully you'll join me next week. And then that'll be the last one of the year, because we're going to be out for Christmas and New Year's. And then we're going to replay this after that. And then we're going to start brand new stuff mid-January. So I won't see you for a couple weeks, but this will be the last brand new class of 2024. And then we move on to 2025. So hopefully you'll join me. If you want to see any of the other new classes or any of the other old classes, they're all available on YouTube. So youtube.com/Snap-on Diagnostics. If you are watching on YouTube right now, make sure you hit thumbs up, like, and subscribe. Make sure you ring that bell, all that good stuff that people tell you to do. Because it really does help with the algorithm and all that. Engagement is good. So anything from ADAS to EVAP and everything in between, they're all free. They're all about half hour, 40 minutes long, depending on the topic. So definitely make sure you are checking those out. It is free diagnostic training anytime you want. Scan the QR code. It'll bring you to the page and subscribe you automatically. Also, do we have your email address? We probably don't. And if we don't, you're missing out on a lot of really good diagnostic knowledge and tips and stuff. Technical focus articles, SureTrack blogs, quick tips, new product releases. They send out my schedule monthly, quarterly, something like that. Here's an example of one on how to diagnose a stretch timing chain, or tips on how to diagnose a stretch timing chain anyway. And then you see right there, sign up for email. So scan that QR code. It'll send you to a form. You can punch in your email address and all your particulars, and then we'll have your email address, and you can start receiving this valuable information. All right. And also, I'd like to remind you that my buddy Keith does free diagnostic training as well. So he does scan tool specific training. So Wednesday is on Zeus Plus. Thursday is on Apollo and Triton tools. One time a night, 7:30 Eastern, 6:30 Central, 4:30 Pacific. Join him on snapon.com/OT. It is Zoom only. It's kind of designed to have the tool in front of you. While you watch what he does on his screen, you can follow along and do what he's doing on your screen as well. So definitely worth your time. About an hour. Then we take a break, and then it's about another 40 minutes after the break. So definitely a lot of content in a short amount of time. Worth checking out if you want to learn more about your diagnostic tool. And that brings us to questions. Once again, if you are on Zoom and you joined a little late and you didn't know how to ask a question, just find that Q&A button top of the bottom of your screen, and you should be able to find type in your question, and I will get to those. Looks like we have a couple I will get to right now. So Jay McCall says hello, checking in, says thanks for the class, good info, thank you very much. And then Maurice says he was looking more on new technologies and more tricks to diagnose and practice. So I gave you a couple of those new technologies there. I mean, not a lot's changed past the leak detection pumps, I don't think. And then a pump's a pump. So you got to turn the pump on with the scan tool. So I guess they kind of go hand in hand, right? So sorry if I didn't give you everything you're looking for, but hopefully you were able to take away a couple of little things with that. And then Jerry asks, where do you know where to hook your smoke machine? So it's going to depend on what you're testing. So a lot of vehicles will have that little EVAP port under the hood. So it's just a little green cap under the hood. And then you just pull that off. And then there's a Schrader valve in there you got to take out as well in order to do that. Let's see. So with that, you go in and you would put the smoke in there if you want to test part of the system. Sometimes you have to go in through the fuel tank. Depends on where it is that you're trying to test. Sometimes you can only check through the fuel tank and the filler neck. That's what I'm trying to say. Or if there isn't a little valve, chest valve there, just pop a hose off and put it in there. It's just anywhere to get it into the system where it can be sealed up, or you can make sure where the smoke goes out, right? Just kind of depends on what you're trying to check. If you don't know where the leak is and you're just trying to find a leak, you just want to find, maybe at the purge valve would be the best place to start. Like pop the hose off the purge valve and pump it back into the system, and then see where it goes from there. I guess probably be your best bet. You do need to make sure you close the vent valve with the scan tool. Turn that off. So that would be a closed system. Okay. And then Kenneth asks, the other guy that does scanners, I need to learn how to use the scanner as well. Yep. So he's the one who does the scanners. So snapon.com/OT to sign up for that. He does the scanners functions with that. We also have some stuff on the website and the YouTube channel as well, if that's not quite your speed. All right, let's go over to YouTube. Jay Lee Lobo says, hello, one more learning day. Let's do it. Yes, absolutely. Always good to be learning something. Nick's checking in from the UK as he does every week at 11 o'clock at night. Get some sleep, sir. Matt Everly says, how are EVAP Systems effective cars living on and driving at 3,300 feet? Well, I'm just going to change the pressures a bit. But I don't think it's going to affect it too much as far as like pulling vacuum, because it's still going to pull a vacuum anyways, right? So it's pulling however much vacuum the engine's pulling out of the system. So I don't think it should affect it too terribly much. The pressure is going to be a little bit lower, but once again, it doesn't check it under pressure, it checks it under vacuum. So as I'm talking through this, my mind is going to I don't think it's going to really bother it too much. Let's see. Motorhead One says overfilling the fuel tank can cause havoc. Absolutely. That's why you want to stop as soon as that fuel pump shuts off, because if you overfill the tank, it could go into. There's also on a lot of vehicles, there's also a tube that goes back to the canister to pull the evap vapors out of the filler neck. There's that word I keep forgetting. Vapors out of the filler neck, collects them back into the canister. So if I fill it up past that and it goes back into the canister, you're going to contaminate your canister. Causes all sorts of havoc. Fuel cap O-ring can cause problems as well, Nick says. Absolutely, for sure. Joel says, I have the same problem with a Tesla. Not sure how you have a problem with EVAP on a Tesla, but if you have an EVAP code on a Tesla, I don't know what's going to happen with that. Matt says, thanks for the classes. And Craig says, car running or no? It's going to depend on what we're trying to test once again with car running. Usually checking for a leak, it's going to be static and car not running. You're just going to have it sit there, just kind of open the system, pump the smoke into the system and see where it comes out, because you're trying to test for a leak. As far as like the readiness monitors and stuff like that, that would be car running usually, just to make sure it passes the monitors. But usually it's going to be car off if I'm just checking for leaks, or I'm actually physically checking the solenoids and stuff. You can function them on and off with the scan tool, check them with the meter with that. Hopefully that answered that question. All right, with that, looks like we have cleared all boards. So I would like to say Thank you very much for spending a little bit of time with me. Hopefully you have learned a few more tips and tricks on EVAP. Hopefully you'll learn me. Boy, I just can't talk tonight. Hopefully you will join me next week for Subaru OEM specific training on Subaru. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.